Hello everyone, so today I'm going to present on our assignment 1 maybe sewerage. So for our group member, including me myself, is SANI Jackson Ahmad SANI, Muhammad NAZRIZAL bin ZULKIPLI, NURUL FATIHAH binti ZEFFRIAN, QISTINA binti AHMAT Alexander, dan Muhammad ASHRAF bin AN-NUR. So the table of content in our assignment today will be introduction, overview of the project, location project, FATI involved, taking of list, query list, schedule of work, real quantity, references, and also appendix.
Assalamualaikum. So I would like to explain on the introduction for this topic. So sewerage works form an essential component of construction projects, particularly in ensuring proper sanitation, environmental protection, and public health. In construction measurement works, accurate quantification of sewerage components is crucial for cost estimation, budgeting, tender preparation, and project control. Sewerage works typically involve the installation of pipelines, manholes, inspection chambers, pumping systems, and associated fittings, all of which require precise measurement in accordance with standard methods of measurement. Measurement works for sewerage construction are carried out based on approved drawings, specifications, and relevant standards such as the Standard Method Measurement (SMM). Proper measurement ensures clarity in the bill of quantities, minimizes disputes between stakeholders, and contributes to effective contract administration. Errors or omissions in measurement may lead to cost overruns, construction delays, and contractual conflicts. Therefore, a systematic and accurate approach to measuring sewerage works is essential to support efficient projects and to ensure that the sewerage system is constructed in compliance with design and regulatory requirements. Here's a little overview of our project. So our project title is Project MENAIKTARAF SEKOLAH MENENGAH Vokasional SIBU KEPADA KOLEJ Vokasional SIBU SARAWAK. So the nature of project is type of work, civil engineering tender drawings, and nature of project, school upgrading and conversion from vocational secondary school to vocational college.
So as we know, our project is upgrading of SIBU Vocational Secondary School to SIBU Vocational College in SIBU, Sarawak, Malaysia. This project is situated at the SIBU, a urban key center in the state of Sarawak, East Malaysia. The strategic location support the transformation of existing vocational secondary school into the modern vocational college, serving an education hub for the region under the Ministry of Education Malaysia to develop infrastructure and development program. On this project, this was conducted at the SIBU Sarawak. Of course, when this construction ongoing, they always have a party involved who will participate for the project. As for the client of this project, of agreeing the project is Ministry of Education Malaysia. Architecture design was architect Reka Sendirian Berhad. Engineering construction, Burning Timor S, SDN Burning Malcha, SDN SBHD. Also followed by quantity surveyor, PB Consulting QS, SDN Ben VHD. So first, let me start with the taking off list. So as we know, for taking off list of the project is always important thing when we come to the measurement. So the first thing for the 300-meter HRPC cover drain, the first item is excavation trenches. The resistive surface of the drainage not exceeding 1 meter, which is in meter cube. Extra over excavation, meter cube. Disposal of surface water is going to be in item. 500 disposal of excavated material meter cube, 50 mm thick thin lean concrete meter cube. Disposal of water will be item, 50 mm thick lean concrete meter cube. Concrete base will be in meter, concrete housing meter, BRC A10 also M2, 300 mm HRPC drain in meter, concrete wall meter cube, 12 mm thick plaster to the wall meter square, formwork to the side of the wall. So the next item, the second item that will be count on this list will be 230 mm HRPC open drain. So as we know, it's almost the same like the previous one, but the difference is only the size of HRPC drain. So on this HRPC open drain, they got the excavation, extra over in rock, disposal of surface water, disposal of excavated material, concrete base, concrete haunching, BRC at 10, concrete drywall, 12 mm thick plaster to the wall, 330 mm HRPC drain, and formwork to the side wall. After explaining about the drain, I will move to the next item, will be sum. So on our project, we're going to measure on 750 mm times 750 mm sum. For the first item will be excavation in pit, which is in meter cube. The second item will be extra over rock excavation, meter cube. And then disposal of excavated material, meter cube, followed by disposal of water will be item, filling to excavation, meter cube, 50 mm thick, concrete also meter cube, concrete base, former to the side of the base, BRC A8, 325 trick equal, 12 mm thick plaster to the wall, concrete top, grade 20, former to the side, concrete top, MS angle plate, and MC grading, followed by connection and the testing. So for the comparison of the above item, they got extra things with each the concrete top grade, formwork to the side of the concrete top, and mild steel, angle plate, and mild steel grading, which is this will be calculated under the sum. So for the queries on this project, there will be the drain reinforcement, BRC A10 meter cube, concrete drain, which is the concrete size to be used is a grade 35. Height of sum is from the PL to the bottom sum. COP radius will be 2. Percentage of rock excavation will be 10%, or you can allow in 5%. For our cases, we're using it 10%. Disposal of excavated material, we assume it will be 20 meters away from the site. While the size of PC 300 mm HRPC cover drain, the query will be 300 mm times 50, 550 mm, and 50 mm. The type of borehole will be used will be the borehole, the trial pit, also the trial pit, and then we also assume there will be existing services, which is telephone wire, and height of telephone service will be 15 meter. We also query the item for the groundwater level. All these items will be used to be used and to be considered to be used for our measurement.
First of all, thank you to SANI Jackson for the explaining on project background and the pre-release and taking off list. So my name is Mohamad ASHRAF, and today I will explaining on the 300 mm HRPC cover drain. So now I will explaining on the 300 mm cover drain. So for this 300 mm cover drain, I will focus on A1 to S1 location. Why I will just explaining on the A1 to S1 location? Because the others location have the same ways of operation. So we will attach at the report, and also right after the sums explanation, we provide to madam a QR code that madam can scan it, and madam can see our others circulation, not only for 300 mm cover drain, but it also for 230 open drain, and also 750 sum for the others location. So now I will explaining on the A1 to S1. So how we got the length is actually we scale using a scale ruler, say with 1 to 100. So with that scale we got 14.8. Then we assuming that we half sum. So the sum is 750, so divided by 2 is 0.375. Then we minus the concrete wall, so it will be 0.15. Then the total for the length is 14.28. Next we will go for the width. So for the width, for 300 mm, as you can see at the image over there, we need to add on both sides of the concrete wall. So each side of concrete wall is 125. So 125 plus 125 plus 0.3 is 0.55. Next is average depth. So for the average depth, as madam can see at the image over there at the left side, so we have a A1 and S1 input level, which is for both of these we use the same PPL, which is 4.50. Then we minus with 4.2 and 4.5 again, we minus with 4.09. Then we divided by 2. Then we got the average of the length of the, we got the average depth for the length of the A1 to S1, which is 0.36. Then we add thickness. So how we add the thickness is basically we just add the concrete base and link concrete. So concrete base is 150 and the link concrete is 50 mm, so it's 0.2. Then the total depth is where you calculate, you add up the 0.36 and 0.2, then you get the total depth for the A1 to S1 drainage is 0.56. So now we will move forward to the excavation. So that we will use the excavation trench. This is a surface water drainage. So the formula is length times width times total depth. So we got the 4.40. So then we go for the extra over in rock. So for this extra over in rock, we use the 10% from the excavation. So 10% from 4.40 is 0.44. Then we go for the disposal of excavated materials. So for our drawing, we doesn't have any filling for the surface water drainage. So the disposal of excavated material is same with the total of the excavation. Okay, right now we will move forward for the link concrete calculation. So as we can see from the previous image, the link concrete thickness will be 50 mm thick. So the calculation will be length and width times thickness for the link concrete. So it will be 14.2 times 0.55 times 0.05. The next will be concrete base and haunching. So both of these are in meters, so it follows the length of the drainage. So it will be 14.28 for both. Then we have a BRC 18. So for the BRC 18, we are going to calculate it with length and width. So 14.28 times 0.55 will be 57.85. Next will be concrete wall. So the concrete wall will be 14.28 times 0.13 times 0.36, and then we times 2 for the both of the wall. So we got 1.34. So the next one is will be formwork to side in the meter square. So length times height and times 4 for the both of the formwork to hold the concrete wall. So it will be 14.28 times 0.36 and times by 4. It will be 20.56. Then we will go for the plaster. So plaster is length times height times 2. So the plaster will cover the internal area for the surface water drainage. So it will be 14.2 times 0.36 and times by 2, and it will be 0.28. Then we have a 230 mm HRPC drain, which is we lay the drain. So for this one, it is in meter and it follows the length of drainage like how we calculate before. So it follows 14.28. So same with concrete subcover, where concrete subcover is where we put the cover on the drain, because this is 230 mm cover drain. So it also follows the length for the drainage. So it will be 14.28.
Assalamualaikum, madam. So for my part, I'll be explaining on the calculations for 230 HRPC open drain. So these are the schedule. So I will be only explain for body 1 to body 2. So as you can see in the drawing, the red lines is indicate for open drain. So the first one is how do we get the length. So since this drain, there is no sum, there's no projections and brick wall, so we just directly scale on the drawing to get the length. So the 2.8 is from the vertical line and 3.6 is from the horizontal, and we plus both of them and we get 6.4 for the total length. And the next one is the width. So the width is just, the formula is the thickness of the concrete wall plus the drain size and plus again the thickness of wall. So the thickness of the wall mentioned in the drawing is 0.1, and the size of our drain is 0.23 plus again with 0.1 the thickness, so we get 0.43 for the width. The next one is the depth. So first thing we need to find the average depth. So the formula is PRL minus the input level for the inlet, for the outlet, and then PRL minus the input level for the outlet. So the PRL for this drawing is 4 meter, and the OD1 input level is 3.7, and for OD2 is 3.58 divided by 2. So we get 0.3 plus 0.42 divided by 2, and we get 0.36 for the average depth. So to get the total depth, we need to add the thickness, since the average depth only covered the height of the concrete wall. So we need to get another thickness, whereas the thickness is from concrete base plus lean concrete. So the total so the thickness for the concrete base and lean concrete is 150 and 0.05. So we get 0.2 for the thickness, and we total up average, and the thickness we get the total depth of 0.56. So we're moving on to excavation works. So the formula for excavation trench is length times width times depth. So we already got our length, width, and depth, so we just times the three of them, and we get 1.54. And next one is the extra overhead rock. We carry for the quantity of rock is 10% from excavations work. So yeah, we just directly times 1.54 times 10%, so we get 0.15. The next one is the disposal of excavated material. Since we do not have any projections or anything else, so we don't have feeling, so we just directly take the excavation quantity equal to the excavated materials disposal.
Next, I will explain about how to count the lean concrete. As we know, the lean concrete for this PC strand will be used as a lean concrete equal to length times width times thickness, which is we get the lean concrete. To get the lean concrete, we need to time all the depth item, which is 6.4 meter. 6.4 meter will be the line, time with the 0.43 will be the width, and 0.05 will be the thickness of the lean concrete. So it equal to 0.14. While for the concrete base, it will be the same as the length of the drain, including the haunching also will be same as the drain. So for BRC AN, the length will be times with the width. With the length, which is 6.40 times 0.43 equal to 2.75. For the concrete wall, we will length times the thickness of the wall times height and times 2 for left and right. 6.40 times 0.1 times 0.36 times 2 will be 0.23 times 2, 0.46. As a formwork, how we get the 9.22 is by timing the length times height times 4 for the kiri kanan and the luar dalam, which is how we can left and right and out and inside will be 9.22, 6.40 times 0.36, which is 9.22. So as for the plastering, the total amount will be 4.61, and for 230 HRPC drain, we go to the length, which is 6.4. While for this item, it doesn't have any base, formwork, and a slab cover.
Assalamualaikum, my name is QISTINA, and I will be explaining on the sum. So for S1, the invert level for P1 is 4.5, and for P2 is 3.31, and the depth is 1.19. Then to get the total depth, we have to add 0.3 to 1.19 to get 1.49. Next, the width is 1.05 meter, and the length is also 1.05 meter. And to get excavation pit, it is 1.49 total depth times with width 1.05 and times with length 1.05, and we would get 1.64. For extra overhang rock, it is 10% from the excavation pit, therefore we get 0.16, and the disposal of excavated material is 1.14. For the disposal of surface water, the unit is item. The gulf for S1 is 4.2, while the area is 0.5, and deduct area RCP 450, so total is 0.5. Then for lean concrete, it's 0.06, and the concrete base is 0.17, while formwork 2 size of base is 4.2, and BRC A8 is 1.1. For concrete wall, the length is 4.2, height 1.29, area 5.42, therefore total will become 5.42. With plaster, the length is 3, height 1.29, and the area is 3.87, then total will be 3.87. For mile steel angle, there is one number, and mile steel grating, also one number. Then we will proceed with testing and commissioning item.
So this is the QR code that I've been mentioned before, so madam can scan the QR code to see other space calculation. So now we will move to the BQ. So the BQ, I will explaining on the preambles, and the rest of this BQ will explain by NURUL FATIHAH. So now I will briefly explain on the 5 notes over here, which is a preamble actually, or we call it a sole description. So these 5 notes has been mentioned in the clause D2 in the SMM2. So this is really important for the contractor to take note before they are doing their excavation. So the first one is groundwater level was established at 3.5 below groundwater level on 3 March 2017, which is the QS assuming that the groundwater level is 3.5 below, so that the contractor will be alert. So next will be the work is be carried out minimum distance of 400 meter from riverbank. So next will be 3 numbers of borehole were sunk in position. The fourth is telephone cable cross over the site of height of 10 meters. So this is important to notify the contractor that there are available services might be at the site. So actually all of these notes we are going to assume. So we already put in the QA list, and the last one will be trial pit at the position shot at the location drawing.
Assalamualaikum, my name is NURUL FATIHAH, and I will explain the bill of quantity for 300 mm HRPC covered drain. First item is excavation works. Excavation trenches to receive surface water drainage starting at finished road level maximum depth not exceeding 1 meter. The quantity is 40 meter cube. Extra over for road excavation trenches to receive surface water drainage starting at finished road level maximum depth not exceeding 1 meter. The quantity is 4 meter cube. Allow for keeping the surface of the site and the excavation free of surface water. Unit item. Remove excavated material on site with average distance 20 meter away from excavation as permanent spoil heaps. The quantity is 40 meter cube. Next item is concrete works. 50 mm thick of lean concrete, grade 15 to receive concrete base to be laid on earth. The quantity is 3 meter cube. Reinforce in situ concrete grade 20 in bed, not exceeding 100 mm 250 mm, including all necessary formwork. The quantity is 115 meter. Next, thick mass concrete haunching, grade 20, ratio 1:3, cement mortar laid on concrete base for 300 mm HRPC drain, including all necessary formwork. The quantity is 115 meter. Layer of steel fabric reinforcement to BRC A10, as described, well lapped at joint and embedded in concrete pad. The quantity is 63 meter square. Reinforced in situ concrete grade 35 wall, 13 meter cube. 12 mm thick cement and sand, ratio 1:3 mortar, trowel smooth for plastering to wall and internal surface of wall, 98 meter square. Formwork to side and soffit of concrete drain of the surface water drainage exceeding 250 mm high, 195 meter square. 300 mm HRPC cover drain is 150 meter. 600 mm multiply 550 mm multiply 50 mm thick precast concrete slab cover in 300 mm wide concrete closed drainage is 115 meter. Next, for 230 mm HRPC open drain, first item is excavation work. Excavation trenches to receive surface water drainage starting at finished road level, maximum depth not exceeding 1 meter, is 4 meter cube. Excavation trenches to receive surface water drainage starting at finished road level, maximum depth not exceeding 1 meter in curved on, is 1 meter cube. Extra over for rock excavation trenches to receive surface water drainage starting at finished road level, maximum depth not exceeding 1 meter, is 1 meter cube. Extra over for rock excavation trenches to receive surface water drainage starting at finished road level, maximum depth not exceeding 1 meter curved on, the quantity is 1 meter cube. Allow for keeping the surface of the site and the excavation free from surface water, the unit is item. Remove excavated material on site with average distance 20 meter away from excavation as permanent spoil heap, as the quantity is 5 meter cube. Next item is concrete work. 50 mm thick of thin concrete grade 15 to receive concrete base and to be laid on earth, the quantity is 1 meter cube. Reinforced in situ concrete grade 20 in bed, not exceeding 100 mm to 150 mm, including all necessary formwork, the quantity is 18 meter. Thick mass concrete haunching, grade 20, ratio 1:3 cement mortar laid on concrete base for 200 mm HRPC drain, including all necessary formwork, the quantity is 18 meter. Layered of steel fabric reinforcement to BRC A10, as described, well lapped at joint and embedded in concrete pad, the quantity is 8 meter square. Reinforced in situ concrete grade 35 wall, the quantity is 2 meter cube. 12 mm thick cement and sand, ratio 1:3 mortar, trowel smooth for plastering to wall and internal surface of wall, the quantity is 18 meter square. Formwork to side and soffit of concrete drain of the surface water drainage exceeding 250 mm high, the quantity is 35 meter square. 230 mm HRPC closed drain, the quantity is 18 meter. Layer of steel fabric reinforcement to BRC A8, as described, well lapped at joint and embedded in concrete pad, the quantity is 3 meter square. Reinforced in situ concrete grade 35 wall, the quantity is 10 meter cube. 12 mm thick cement and sand, ratio 1:3 mortar, trowel smooth for plastering to wall and internal surface of wall, the quantity is 7 meter square. Formwork to side and soffit of concrete drain of the surface water drainage exceeding 250 mm high, the quantity is 9 meter square. Supply and install 310 mm multiply 750 mm thick heavy duty mild steel grating complete of 45 mm multiply 6 mm thick mild steel plates as frame and fixed in, the quantity is 1 numbers. On completion, allow testing to all surface water drainage for water tightness, make good any defect, and leave everything imperfect, the unit is item. Supply and install 45 mm multiply 45 mm multiply 5 mm thick mild steel angle plate, all welded together, the quantity is 1 numbers.